Well, hello again and welcome to the fourth problem of the recursive problem set. So here it says the Tour of Hanoi is a famous puzzle, and it is, basically. It consists of 3 roads and a number of discs of different sizes. So here we have 3 rods, rod 1, 2, and 3, and we have basically a variable number of discs. And the puzzle starts with the discs in a neat stack in ascending order of size on one road, the smallest at the top. So let's get down here. And it says the objective of the puzzle is to move the entire stack to another rod, obeying the following simple rules. So we have to take these rods from this first, these discs from this first rod and put them here, the third rod. So we have to respect these rules in order to do that. So only one disc can be moved at a time. So you have to take one disc at a time. You can't, for example, take 2 or 3 discs just with one grab. You have to take them one by one. And each move consists of taking the upper disc from one of the stacks and place it on top of another stack. And a disc can only be moved if it is the uppermost disc on a stack. So basically you keep taking one disc from one rod and put it inside another rod, and you can only take one disc which is the uppermost disc. You can't, for instance, take this orange disc because there's a bunch of other discs on top of it. And the third rule is no disc may be placed on top of a smaller disc. So the smaller has to be placed on top of the bigger. You cannot place a bigger disc on top of a smaller disc. For example, we cannot place this red disc on top of the brown disc. Okay? So here's a legitimate situation here. So the brown disc is smaller than all of the discs below it. Same thing here and the same thing here, and we can only take one disc at a time, which is the topmost disc. And the result must look like this. So we've been able to successfully take all the discs from the top left rod to the from the leftmost rod to the rod at the right. So it says here, write a C program which takes an integer n, which is the number of discs, and prints all the required steps to move all the discs from rod 1 to rod 3. And here's a simple input. So for example, if I give you 3, then we're going to have to take one disc from rod 1, put it inside rod 3, and then from rod 1, put it on top of rod 2, and so on. From 3, put on 2, from 1, put on 3, from 2, put on 1, and so on. So how are we going to do this? How can we solve this problem recursively? Well, basically, to think of this problem recursively, we basically have to think of all of these rods here. So this bunch of rods, these discs, sorry. These discs here, you're going to have to think of them as if they are just one single disc. And your job is to take the blue disc from the first rod to the third rod, right? And if you consider that all of these discs are just one disc, then you can take that entire disc and put it here to the second rod, and then take the blue rod to the blue disc to the third rod, and then you can take the bunch of discs here, which we consider to be one disc, back on top of that blue rod. Okay, so let's draw the situation here. So we have a blue rod here, that's a blue rod, And then we have all of the other rods. Let's consider them to be green. So these are the green rods. And then we have to move those green rods on top of the blue rod. The green discs on top of the blue discs. I keep saying always replacing the discs with rods. But you got the idea. But then we ask ourselves, how can we sort of move all of these discs from the first rod to the second rod? And then we have to solve another sub-problem. Then again, we're going to forget about the blue disc, and then we're going to think of the remaining disc as if they are two sub-problems. The first sub-problem is this bigger disk, just one disk that contains all of those disks, and another pink disk. So our job is to take that that disk on top to a temporary place in order to move that pink disk to the desired location. And then we can take that back from the temporary location to on top of the pink disk. And the same thing again and again for all the sub-problems. So basically, we take all the rods except the last one, all the rods except the most bottom one, we take them from their place to another temporary place so that we can move our top most bottom disk to our destination, and then we take all of the other disks on top of that disk. And the same thing happens for all the disks. So if we want to write some C program, some algorithm to do this, let's do a function f, or it could be Hanoi, or whatever you want to call it. So the function f always takes the number of disks we have, so that's n, and it also takes the start from where we're gonna get the disk, the destination, where we want to put the disk, and another third variable which contains which is temporary, which contains the number of the temporary rod. So TMP, that's temporary. And basically we said that we have to do two things. So the first thing is basically to call f with n-1, of course. So that's, we always decrease 1 from the numbers of disks. So we have to call f with the start as the start, because we're going to take a bunch of disks from the start node. So let's say this is start, this is temporary, and this is destination. So we want to take all of those disks from start and put them inside TMP. So our start will be start, and our destination will be TMP. And for the TMP, it's going to get the destination. Okay, so our first disk, which is a set of all of these disks, we're going to take it from the start and putting inside a temporary place. So we're going to take it from start and put it inside its destination. Its destination will be the temporary rod. And then we want to print to the screen what we did. So let's print what we did. So we're going to print the start and the destination. So we're going to print the start, and then some arrow here, and then the destination. And then we're going to call f again so that we can take the disk, the top bottom disk, from the start to the destination. Okay, so let's do that. So that's n minus 1, and we want to put the disk from the start inside the destination. So we did that when we printed that to the screen. Now, what we have to do is to take the big disk, which contains a bunch of other disks, from the temporary to the destination on top of our blue disk. Okay? So we want to take that from the temporary on top of the destination. So our start will be the temporary because we're taking disks from the temporary rod. So our start is the TMP, and our destiny will be the destiny itself, and the temporary is the start. So basically that's a real quick pseudocode for the idea. Again, it's really tricky to think of this problem, to think how to come up with a solution recursively, because the tricky part here is that for every recursive call, the start rod, the temporary rod, and the destination rod are being changed on and on and on and on. So for the first problem, this is the start, this is the temp, and this is the destination. But when we try to solve the sub-problem, basically the temporary will be not the temporary rod, it'll be the destination rod, and the destination rod will not be the destination, it'll be the temporary, because again, the naming of these rods is relative to that sub-problem itself. So every sub-problem has a different way of looking what is the start, what is the destination, and what is the temporary. So let's write this again in a whiteboard in a clear way. So I'm gonna open up a new sketchpad here, and we said that we have a function f that takes n, and it takes the start rod, the destination rod, and it takes the temporary rod. And that function basically will keep executing for all n bigger than 0. So if n is bigger, I think it's bigger or equal than 0, we're going to test that later. In that scenario, we're going to call the subproblems with n minus 1. So we're going to call f of n minus 1, and then the start is the start. We're going to take a bunch of disks from the start and put them inside the temporary, so our destination is the temporary, and the temporary is the destination. And then we're going to print start, and then an arrow, and then the destination. We're taking a disk from the start to the destination. So this is the standard output. And then we're going to call f again to take all of the disks from the temporary, the disks that we put inside the temporary, we're going to take them from the temporary and put them inside the destination. So the temporary is the start. So the start will be replaced by the temporary because we're taking disks from the temporary rod. And then our destination is the destination itself. And then finally, the temporary rod would be the one that we did not use. So we used TMP, we used deth. So the one that's remaining is start. And if, and f. So let's try to code this. Let's test this in a C language, see if it works. So here I opened code blocks, and I'm going to write the function f. So it's of type void because it does not return any value. So that's f. And we said that the function takes the number of disks n, and it takes the start, and it takes the destination, and it takes a temporary rod. And we said that we have to check if n is bigger or equals, that's bigger or equals to 0, then we're gonna call f with n minus 1, and the start is the start, the destination is TMP, and the TMP is the destination. And then we're gonna print two integers and an arrow between them. So that's an integer and another integer. And the first integer that we want to print is the start and then the destination. And then we call f again with n minus 1 so that we can take a bunch of rods from the temporary and put them on top of the destination. So our start will be the TMP because we're taking disks from the TMP, and our destination is the dest, and our TMP is the start. And now let's see that. Let's say that our n equals, something like 0, for example. No, not 0, something that we can like test with. Let's say that our n equals 3, for example. And we're gonna call f with n, and our start is rod 1, our destination is rod 3, and our temporary rod is rod 2. For n here, I think it should be bigger than 0, because if the number of disks is 0, then we have nothing to move. We have nothing to play with, in fact. So let's run that, and as you can see, these are the 7 steps required to solve the Tour of Hanoi for n equals 3 disks. So 1, 2, 3, 4, 5, 6, 7. And by the way, this is the optimal way to play this game. So we take from disk 1 to disk 3, from rod 1 to rod 3, from rod 1 to rod 2, from rod 3 to rod 2, from rod 1 to rod 3, from 2 to 1, 2 to 3, and 1 to 3. So if you have a Tour of Hanoi game in home, then if you write this algorithm and you follow the instructions in the output here, then you're gonna be able to solve the problem in the most efficient way. Also, if you do not have the game at home, then you can download from the internet some digital versions of the game. You can find, if you're using Android, you can find an app, a game called Tour of Hanoi from the App Store, from the Play Store. Or if you're using iPhone, then you can basically find the App Store some games, Tour of Hanoi, and then you can experiment with them using this algorithm. That will be a really great exercise to understand recursion. Basically, for the Tour of Hanoi, the optimal way to play this game is to make sure that the number of steps you're going to follow are exactly equals to the number, to 2 times the number of disks minus 1. So if we have 3 disks, then 2 to the third equals 8 minus 1, that's 7. So you have to play this game in 7 steps. If you do 7 steps, then that's the optimal solution. If you do bigger than 7 steps, then, well, you're making extra steps that are not required to solve the problem optimally. Thanks again for watching, and see you at the next exercise.